Hello friends, let's see what this question has in store for us. As you may know, feel free to pause the video anytime and use your brain and think and try to anticipate where I'm going with things. Make sure that you are doing some thinking ahead of me so that you're not just listening to my thinking, but you're following along and perhaps even thinking ahead. So my first goal when I'm looking at this free response question is to figure out what information I have. Once I know what information I have, I can more easily process whatever questions they're going to ask of me. When you approach a free response question, first thing you should do is look at what the stem of the question, that's before we get to kind of the ABCD, says, and you should try to figure out exactly what information I have and how it can be helpful and that sort of thing. Okay, so let R be the region in the first quadrant, bounded by the y-axis, the graphs of y equals 4x minus x cubed plus 1, and 3/4 x. So R is this region right in here. If I wanted to find the area of R, I would need to figure out the area under this curve until the intersection point, and then the area under this, which is just a triangle, until the intersection point. Now, for the first curve I drew, this curve, I would need to integrate. For the triangle, I could just use geometry and find the area of that. Now, I'm not sure exactly what questions they could ask me, but they could ask me things like the area of R. They could spin R around an axis, hopefully an axis like the x-axis or y equals -2 or something like that. And that's about all I can get from the stem of the question. I will probably need to find the intersection point, but I can go ahead and use my calculator to figure out what that intersection point is. Hey, as I said, one of the questions they're going to ask me is how to find the area of R. So I'm going to go ahead, maybe I'll make this picture even bigger for us. I'm going to say, let's figure out the area under this curve first. Now, before I can do that, I need to figure out where these two things intersect. If you have a graphing calculator, feel free to put these into like y1 and y2 or whatever your calculator chooses to do, because we're going to need to use them throughout. And you're going to need to find that intersection point, which your calculator can figure out for you. My calculator is telling me that I have an intersection at x equals 1.94. I'm going to go ahead and call that B. You could store that in your calculator if you wish. If you have a TI calculator, that's right above the on button. It says STO. Feel free to store that exact value in your calculator. So now my job is to figure out what this area is. So that deals with the cubic. So I'm going to integrate the cubic from 0 to my B value. And I'm going to integrate 4x minus x cubed plus 1 dx. This is a calculator question, so I can go ahead and type that in. Integrate 0 to B and then the function, and I get 5.9266. So I'll call that 5.927. Now I'm going to find the other area. Let's get rid of this. I'm going to find the other area in two different ways. One way is perhaps the first way you would do it. It's the same idea as what we just did. I'm going to integrate from 0 to b, but this time I'm going to integrate my 3/4 x dx. So I will go ahead and do that. And I'm going to get, same integral, 1.4119. So 1.412. Now, to find the area of R, I would add those together. But I'm not going to do that yet because I said I was going to find it in two different ways, and then I'll talk about a third way that I could actually process this question. So to find the area of this triangle, if I wanted to, I could just, I know what this is 1.94, and then I could figure out what this height is. It's 3/4 times 1.94. So then the area of my triangle is going to be 1.94 times 3/4, 1.94, divided by 2 because it's a triangle. That should get you the same 1.412. Now, if you wanted to, you could also write it as one big integral. You could integrate from 0 to b. You could say 4x minus x cubed plus 1 minus 3/4 x. I think I said add them together before, but I should be subtracting them. That was silly of me. Dx. I'm subtracting because the purple region, that first region, gives me the whole area. I'll color that back in. The whole area. But then I need to take out that orange triangle. So if I go ahead and do that subtraction problem, I got 5.927 minus 1.412. I got 4.515. So 4.515. And that's it for that part. Let's see what this has. So for this one, the volume of the solid generated when R is revolved about the x-axis. Now, this is going to be a similar thought process. What I'm going to do is I'm going to take this figure here that I've already talked about, and I'm going to find the volume of that. So the radius is simply this curve. So 4x minus x cubed plus 1. When I spin this about the x-axis, that's going to form a circle or a disk. So the area is going to be pi times that radius squared. I'm going to say the area of the big because I'm going to have a little also. And then the volume of the big is going to simply be add up all those. Because as I spin these, you're going to have circles kind of this way. As I spin those, I'm going to add those all up. I like to think of it as like a bologna loaf, but maybe that's gross to some people. Again, I'm going to go 0 to b. And I'm going to write pi, the radius, squared dx. So I'm going to go back to my calculator. And into my calculator, I'm going to put the same thing. I'm going to put my function and square my function. Don't forget pi. I forgot pi. So I got 61.767. 61.767. Now, I also have this little triangular region. Its radius, so little radius, is just 3/4 x. And so the area of the little radius, maybe I should say little, is pi rad squared. Because again, we have a circle. So then the volume of the little is going to be pi integral 0 to b little radius squared dx. And if I am to do that, then I get 4.304. 4.304. To figure out the overall volume, I would need to subtract those. Now, you may be asking yourself, can I do this all as one big step? Of course you can. If you're going to set this up as one big step, you're going to integrate from 0 to b, put the pi out front, and put your big radius, 4x minus x cubed plus 1 squared, minus your little radius, 3/4 x squared dx. So when I do that subtraction problem, I'm going to get 61.767 minus 4.304, 57.463. 57.463. Hopefully I'm not messing up any rounding. It may be a better idea to go a few more digits here. I've just been a little bit lazy. Part C. R is the region of the first quadrant, bounded by that. I'd forgotten to paste the question, but now it is there. Write an expression involving one or more integrals that gives the perimeter of R. Okay. So I have a whole bunch of pieces here that I need to think about. let's take care of the easiest part, maybe. So let me move the question down here and let me make the picture bigger so we can play. So I think the easiest part is going to be right here. That's just 1. So maybe on the y-axis, we get 1. How do I know that's 1? Because of this function. 4x minus x cubed plus 1. If I plug in 0 for y, try again. If I plug in 0 for x, I get 1 for y. So that's that distance. Maybe the next easiest distance is this one. I could use calculus, we'll show that in a minute, but I could also just use geometry. I know this is 1.94, and this is 1.94 times 3/4. So if I just do the Pythagorean theorem, so on 3/4 x, we're going to get the square root of 1.94 squared plus 1.94 times 3/4 squared. And if I grab my fancy dancy calculator here, square root 1.94 squared. Again, you should use the exact value. Hopefully my lack of using the exact value won't hurt me. And I get 2.425. So that's 2.425. Ran out of room there. That looks silly. I'm going to fix that. 2.425. 2.425 is 2.425. Now, I could also do calculus on that. What is another way to figure that out? So if I want arc length, if we forget how to find arc length, it has to do with the Pythagorean theorem. So let's do a quick recap of arc length. So for arc length, I need to know the change in x and the change in y, and that will tell me what this length is, because I can use the square root of the change in x squared plus the change in y squared. And then, since this is calculus, we're going to do each of those steps super small. So we would say, okay, this change, and then this change, and then this change, and this change. Obviously, it would be even smaller than that. So I would add all those up. So I would integrate from a to b, in this case, 0 to b, my delta x's, my delta y's, and write it, but I would need, I should get more mathematical on you, I'll do that. I would need to turn this into the calculus we are familiar with, because we write this as a Riemann sum, really is how we would break it down. So let's think about this. If I wanted to write it as an integral, 0 to b, square root of dx squared plus dy squared, well, I need something out here. So what I want out there is a dx. In order to make that happen, I just essentially multiplied by dx, so I better divide by dx so that I undo it. Let's slide that underneath the integral. So, I'm sorry, the square root, but when I put it underneath the square root, it better become squared, so dx squared plus dy squared over dx squared. Now let's simplify that expression, and what you're going to get is dx squared over dx squared is 1, dy squared over dx squared is dy dx, or the derivative, squared, and then dx. So theoretically, if I go back to my triangular region, if I integrate 0 to b, the square root of 1 plus the derivative, so 3/4 squared dx, I should get the same answer. Let's go ahead and put that in my calculator and see what I get. Integrate from 0 to b, square root 1 plus, I'm going to get spicy and write 9/16 because I know what that is, and I get 2.4255. So basically the same answer. 2.4255, so I'll write that, 55. Okay. Now the next region is this region, and based on the calculus we just talked about, I know how to do that. Integrate 0 to b, square root 1 plus 4 minus 3x squared. Now, if you're confused, go back up here. The derivative of 4x is 4. The derivative of x cubed is 3x squared, and the derivative of 1 is 0. And then dx. So, put that back in my calculator. 4 minus 3x squared, and I get 6.17455. 6.17455. 6, whatever. So if I add up my numbers that I just figured out, I got a 1. I got a 2.425 and a 6.1745. So I got 9.6 as my total answer. So 1 plus 2.4255 plus 6.1745 equals 9.6. Okay. Let us recap. We were given these two curves. We had the cubic curve and then the linear curve, or line if you want to call it a line. First thing we had to do is find the area of r. That was just the difference of the two functions as we integrate. So we integrated 0 to this intersection point, which I called b, and I did the top one minus the bottom one. Part b is quite similar, except we have a volume, and that means we're rotating, so we're spinning about the axis, so we're forming circles. So we did pi r squared of each of those circles, and then we added up pi r squared of those. And the final piece, we wanted to find the perimeter. To find perimeter, we just had to say, okay, what are the pieces? So that was a 1, that was just a line, we could use the Pythagorean theorem, and then this one we had to actually do calculus for. And to do that calculus, it came from the Pythagorean theorem, and that was that arc length formula. You may have learned the arc length formula is 1 plus, does depend on if you want to write dy dx or f prime, doesn't matter. So I wrote it that way. And let's see how we did. So 1.940 is what we had for our intersection. I think we got that for our area. In our volume, you could have left it in terms of pi if you wanted to. Oh no, I didn't listen to the question. So that's where I messed up. I never actually had to do the calculation. So my answer should have been, I was so excited to figure things out, my answer should have just been this piece here, which essentially I already had. I did this. I wrote an arc length integral, so I would have lost the answer point because I actually found the answer when I wasn't supposed to. But that's it.